Welcome to the AAA tutorial on the Loads module. The Loads module has three submodules: VN diagram, structural, and lateral gust loads. The VN diagram is the first one. So here we're looking at the flight condition parameters as input. Then we see CLmax and CD at that CLmax. We see the maximum negative lift coefficient, the drag at that maximum negative lift coefficient, and you see CLmax, which has the flap effects included. Then you see some aerodynamic parameters, as well as some of the airspeeds, which are the design equivalent cruise speed, maneuvering speed, level speed, and dive speed. Here we are going to take a look at the plot. And the plot is basically the VN diagram for, in this case, the Cessna 172. So we see here the red gust lines. The curved part of the green maneuvering diagram is where the maximum normal force coefficient is achieved. You also see the different speeds for the maneuvering diagram. So you see here VS clean, VA, which is the maneuvering speed, VC is the design cruise speed, and you have VD, the design dive speed. The next module in the loads module is the structural loads. And structural loads is including the main components like wing, horizontal tail, vertical tail, and fuselage to calculate the loads on the Cessna 172. Each of these modules look very similar. Basically, you're going to assign weights or forces to this particular component to basically calculate the internal loads and moments. Let's take a look at concentrated weights. And for the concentrated weights, you can add components, you can select components, and you can copy tables, and you can select the concentrated weights. Basically what you're doing here is you're selecting particular components, and you can also add user components, and you're going to add them, and eventually you can see what the weight and CG is for each of these components, so the program knows where to apply that weight force. You can basically look at any of these categories, and you can have multiple categories at the same time. Similarly for the distributed weights, here we can see, if you select components, that the distributed weights, for example, is the wing itself, but also the fuel and the trapped fuel and oil. Then we have the aerodynamic loads, and the aerodynamic loads are the steady state loads, the control forces, there's concentrated aerodynamic forces and distributed aerodynamic forces. Next is the load stations. In the load stations, you'll define the load stations in the span-wise directions at which you want to calculate the loads. In this case, we defined it at 21 stations. One reminder is that the last station here at the bottom cannot exceed the wingspan divided by 2. In this example it is, and if you hit calculate, you'll also see that warning pop up. So let's change that to 211 because that will be inside our half wingspan, and then if you hit calculate, you'll see that that warning no longer shows up. Then after the load station, there's the gear, engine, and miscellaneous loads, and here we see different components like nose gear, main gear, and the engines, their location and the forces that they induce on this component. And here we see that it's also attached to the fuselage, so it will not have any effect on the wing. The last is the internal load calculation. So here we can select each of the components that we want to include. If we say continue, you basically will see input parameters and an output table. And most of these input parameters include wing geometry, as you can see here, CG location, accelerations in X, Y, and Z. And lastly is also that you see all the loads combined. So here from left to right, we have the chordwise shear for the left wing and the right wing, the normal shear for left and right, the bending moment in X, the bending moment in Y, the torsion, and the actual forces in the last two columns. If we hit calculate, the forces will update And then you see also that all these components are recalculated based on the new condition. This is available for each of the components that are present on the aircraft. And each of these components can have different weights attached to them. So you can see it's very similar for the horizontal tail, the vertical tail, and the fuselage. There's no canard or V-tail in this case. Lastly is the lateral gust loads submodule. The lateral gust loads module only applies to FAR 23 certified aircraft. And here we can basically calculate the lateral gust load at the different speeds, the cruise speed and the dive speed. That sums up the loads tutorial. If you have any questions or suggestions for new tutorials, feel free to reach out to us.